Hi there, this is Upakarat Naik from Civil Engineering to present my research work in a kind of a tough year. Before I particularly present my own research work, let me spend a couple of minutes on the work done by our water group in civil engineering. Dr. Anth Gomez is heading the Applied Ecological Engineering subgroup, and he was able to come up with 6 index journal papers, 1 conference paper, and 2 newspaper articles in 2020. Out of these index journal papers, 2 journal papers are Q1 journal papers. Then Mr. Susantha is heading the Hydrology and Irrigation Engineering subgroup, and he showcased 1 index journal paper publications, which is again a Q1 journal paper. Then I myself am heading the Water Resources and Climate subgroup. It was kind of a good year for me in the context of the publications, as I was able to come up with some good research work in 2019 and probably in early 2020. So I was able to get 11 index journal papers, plus 2 conference papers and 1 newspaper article. Well, out of these 11 index journal papers, 2 journal papers are again in Q1 category, and most of the others are in Q2 category. Now, these journal papers are based on my current research interests in the paths of like optimal control of urban water systems, and then in impact of climate change on agriculture, and also along the lines of impact of climate change on water resources and hydropower. Here, I have listed these publications for you to have a wee look. Now, these are the first 4 journal papers. And then we have another set of journal papers, which takes up to 8. And yeah, the total number of 11 journal papers. Then we have 2 conference papers, as I said earlier. So and with a newspaper article. Like out of them, today I'm going to present the research work which was carried along the lines of projection of future hydropower generation in Samanalawewa Powerplant in Sri Lanka. This was published in Mathematical Problems in Engineering, which is a quite good index, Scopus Index and SCI Index journal. Now, it's like this. My idea is to develop a relationship which we can use to find future hydropower generation. Therefore, let me take the point option. Probably it would be better. Yeah. Therefore, a relationship, like an equation. Power generation is equal to a particular function to the rainfall, is presented in this particular research paper. Now, we have no idea about this particular function. What we know is it could be a nonlinear function. However, we all know the power generation is a function of runoff, that is the catchment runoff, and storage capacity of the reservoir. Therefore, it is well acceptable to have an equation which states power generation is a function of rainfall. Now, I selected Samanalawewa Reservoir as the hydropower station due to several important reasons. One for sure is the data availability. To tell you all, obtaining power generation data, that is the historical power generation data from the relevant authorities, is one of the most difficult items in this research. Now, you can see the catchment of Samanalawewa, and the enlarged image shows the reservoir area. And also some of vegetations around the reservoir, like the reserves. And we have several rain gauges. Luckily, these rain gauges are kind of spread over the catchment area. And this particular figure shows you the spatial variation of rainfall to the catchment, say for 20 to 25 or maybe 30 years time. And we can clearly see that the Samanalawewa catchment area receives a significant amount of rainfall over the years. Now, a model based on neural network, it's a neural network model developed to showcase this particular function. Power generation is equal to a function of rainfall. Using the catchment rainfall data and the power generation data for 27 years. Then the artificial neural network was calibrated using the known measured power generation to the predicted power generation. Then the predicted power generation was matched like a calibration for year 2018 or test. It was a kind of a test for year 2018 and 2019, which the data were not used to model the system. Now, this particular figure shows you the testing of the results. We can clearly see that the R-squared value for the actual power generation and the predicted power generation is 0.83, which is quite good for climate analysis. Next, the projected future rainfalls were extracted and models using the RCMs. Now, that is regional climate models. We use these 4 regional climate models and 2 RCPs, that is, they are based on Intergovernmental Panel on Climate Change, RCP 4.5 and RCP 8.5, were used to obtain the future rainfall, like in 2035, probably in 2050s. Then the model was run to project the future power generation using the projected rainfalls. Now, the outcome of this research is clearly seen from this particular figure. You can see the projected power generation until 2050. We run the model for 2050 for 2 scenarios, that is, they are RCP 4.5, RCP 8.5. Therefore, these results can be effectively used for any potential planning purposes. Now, that's all about what I was thinking to talk about the research work. Anyhow, before I wrap up the presentation, I would like to talk a bit about our proposed work in 2021. I obtained 2 RAs from the research SLIIT research grant, and also we are moving to some new dimensions of the image processing. Let me showcase this figure and wrap up my presentation. Thank you very much.